Değerli katılımcılarımız, konferansımızın ilk günün öğleden sonraki programı başlamak üzeredir. Programımızın öğleden sonraki kısmına tekrardan hoş geldiniz. Şimdi konuşmasını yapmak üzere huzurlarınızda Turkcell Genel Müdürü Sayın Doktor Ali Taha Koç Beyefendi'yi sahneye davet ediyoruz.
Evet. Distinguished guests and dear visitors, I would like to welcome you all. So this is going to be the first time that we're going to switch to English. So I'm pretty sure that we're going to continue as in English. Değil mi hocam? Tamam. Yani Türkçe de olur da. Okay. So first of all, I just want to congratulate everybody who is contributing on this conference, because at the end of the day, this is an important conference for all of us. But I just want to especially thank one person, and Hüseyin Arslan, for stubbornly, effortlessly, or I don't know, I couldn't find adjectives for that effort, but he is always constantly moving to make this conference a solid conference. So years pass, but his success is always there. So I just want to, in front of you, again, I want to especially congratulate and thank Hüseyin Arslan for this conference. So it gives me always a great pleasure to talk about new technologies, and actually this is the perfect time right now. We have to think about 6G, we have to talk about 6G, we have to discuss about 6G. So that's the reason that this is a very good platform for all of us to discuss the topics and come up with the fruitful outcomes. Because if you don't think about it, you cannot produce it. So that's the reason that we definitely need to talk about it, especially talking about others instead of talking about technologies are new way forward for all country, for our improvement. It's a very important topic for us. So the first G workshop was held in Istanbul, according to my notes, in 2017, and was made possible by, again, with Ediburgh University and Professor Hüseyin Arslan. But to say the truth, that when we talk about the 6G, I always say that it is a big transformation, it's a big change. So the transformation from the big data, which, as all of us know, is grown exponentially, to a meaningful data. So with the help of 6G, we are going to convert or transform big data into meaningful data. So in fact, this evolution is not only a story of technological advancement, but also how innovation will shape our world and our lives. As we all of are aware, the world is undergoing a technological transformation. So transition from connectivity for everyone to connectivity for everything. From everyone to everything. So this topic will change, and we will discuss a lot about this topic, but I just want to go back. I'm getting old, so if you're getting old, you need to talk about the history. But I just look at my PhD times, and I went to and check one of my PhD papers. It was in 2004, long time back. And I look at the title of this paper before coming here. The title was Simulation-Based Analysis of Random Access CDMA Networks. Still, someone is working at CDMA networks at that time. I was one of them, and then as a PhD candidate, I was working in the CDMA networks. So at that paper, I just found that one sentence that I want to rephrase. Allow me to read it. As large mobile networks have become commonplace, the allocation of resources has become critical. The most important and restricted resource is the system bandwidth for this kind of network. So still the bandwidth is an issue, 20 years pass, but we are talking about the bandwidth. So nothing changed actually, the only thing is that we are getting old, right? So as an academic and an engineer, I could anticipate the necessity of bandwidth and its significance. But to say the truth, that I just looking back and then trying to understand what I miss is definitely I never ever imagined that we could be confronted with such a substantial amount of data. So I can guess that the bandwidth is needed, but this amount of data, exponential growth of data, is something that I missed. So Let me talk about the connectivity and then all the technologies. We start with the three voice calls, and after that with all the digital services, the new technologies. Every 10 years we are having a new technology with the naming is changing. To say the truth that I need to stop some point, right? So this numbers theory needs to end. 2G, 3G, 4G, 5G, 6G, 7G, 8G. So sometimes it's just an upgrade. So that's the reason that we need to come up with a common methodology. So instead of having just a marketing naming, so we need to come up with, if there is a need for a technology, we need to change the name. So every 10 years, this is just like a employment structure. When I was working at Intel, when we talk about the LTE, so as you know, the LTE stands for long-term evolution. But in Intel, what we call it, long-term employment. Because when we start working on LTE, it's always you work on it, so then you are not going to lose any job. So to say the truth that, we need to put some meat in it actually. So if it is a need, if there's a need, we need to change the name. Otherwise, it is becoming a PR campaign. Oh, this country has 5G, this country has 6G. But at the end of the day, it is all user experience. Are we providing the necessary user experience to our customers? It doesn't mean if it's going to be 2G, 3G, 4G, but at the end of the day, it boils down to the experiences. So 4G and 5G actually bring this some connectivity, but at the end of the day, the impact that this connectivity has on our everyday lives, industries, methods of conducting businesses. Actually, what are these? If we go through that, there's a huge transformative powers of wireless communication, including smart cities, smart homes, connected vehicles, digital wallets, and wearables. The most critical requirement for this technological integration, which transform industries while also increasing human potentials, is still bandwidth. But besides that, we need to think about difference between everyone and everything. These two words have some common words in it, but actually there is one more thing is coming, everywhere. So by everywhere, I mean cyber-physical living or space-independent interactions. Thanks to the adaptability that it will bring to the architecture of new technology, 6G will make it possible to achieve significantly higher level of connectivity. But to say the truth that when we talk about the bandwidth, I want to emphasize another thing about the, last 20, 25 years, all of the engineers are working on the coverage issue. Still, we have the coverage issue. So it is not possible to fix all the problems. Because why? Because before that, we have all these small buildings. Right now, we have high-rises with concrete buildings. Before that, we don't have huge stadiums or huge shopping malls with concrete. So every time we need to have a problem, fixed problem. Bandwidth is scarce and connectivity or the coverage is going to be always a problem. Besides that, with all the high demand, the coverage becomes on-demand based coverage. Because most of the operators are thinking about when they are building their infrastructure, they are thinking about like a fixed deployments. But thinking about the locations where there's a huge soccer game, like 2 days ago, because as you may know, Turkey is a soccer fan, and then everybody loves soccer. But overall, for that stadium, we needed definitely a couple of hours of huge demand. But a couple of hours later, there's no need for any demand. So that's the reason that for the cost perspective, as well as the user of experience perspective, we have to come up and we need to change the KPIs, call it, what about the coverage? Because covering everywhere is not the possible solution. So we need to think about it where and when to cover. So if you look at that, all the requirements of all the regulatory body, everyone's saying that they forget about the time axis, right? They always talk about the area axis, to cover all this region, cover the places where the population is there. But when? Then we need to put another requirement for that perspective as well. And I will talk about that in my talk a little bit more. So connected with the 6G, we definitely need to think about it. We are not connecting people anymore. We are connecting intelligence and complex systems together. However, as everyone knows, 6G technology entails more than just providing significantly faster internet or connections. The revolutionary technologies I just described and their results will shift the completely different place with 6G. Actually, this is not an upgrade. To say the truth, that if you think about it, from 4G to 5G is an upgrade. But from 5G to 6G, it needs to be rather a paradigm shift. So in other words, a new phase in which we will link intelligence, not people, not things, but in the 6G domain, we are going to connect intelligence. So what will change, if you ask my opinion? First of all, when 6G is implemented, again, the latency is not going to be any problem anymore. It is possible to create networks with, that are significantly denser. In the cyber-physical age, holographic projections will allow us to do many, many crazy and fancy stuff. Especially instead of doing a physical meeting, we're going to do a holographic projection meeting as well. To put in another way, the 6th generation wireless networks will introduce a digital world in which data is processed by artificial intelligence. So we need to think about the 6G as a data generation factory. And this data generation factory needs to be evolved or processed by artificial intelligence. So we need to change our mindset from going from the telecommunication industry or all the electromagnetic waves or signals. We need to think about as 6G as the data warehouse or data factory, which is going to create enormous amount of data. So not only will it connect the digital and the physical world, but it will also seamlessly integrate them into the new virtual dimensions. Let's take a break, and in the 6G era, what will we witness? We will witness the convergence of 3 distinct worlds. I don't know if you have these 3 distinctive worlds in your life, but actually everybody has these 3 distinctive worlds. A digital world, a physical world, and a virtual world. So the 6G era is going to convert or combine all of them, and then in this world, we are going to have humans and machines will have the opportunity to experience something completely new. But currently, what we are going to talk about is always we, as an operator, we always say that we need to provide the best experience to the humans. Right now, with the 6G, we are going to come up with a KPI saying that we are going to give the best experience to machines. So our market or our customers is going to change. The number of the customers is going to change. The mentality or the physicality of the customers are going to change from human being to machines. The device will be truly intelligent, hyper-adaptive, and highly flexible, autonomous in the 6G environment, which marks the dawn of the Internet of Everything, I/O. So with the 6G, we're expecting that when we are talking about currently with the IoT stuff right now, with the 6G, we need to start talking about the IoE. And maybe there's a different methodology, or they are calling Internet of Bodies as well, but we definitely need to talk about the Internet of Everything concept. Artificial intelligence technologies will use human interfaces to interact more naturally with their physical surroundings. This indicates that machines, systems, and even human intelligence will engage in collaborative efforts, learn from one another, and interact in ways that have never been seen before. So right now, we need to get used to talk with the machines. We need to learn from machines. So with the 6G era, it's going to be a different world where these 3 different worlds are merged to each other. New levels of human-object interaction will be unlocked, so we can refer to the development of 6G technology as disruptive technology, one of a kind disruptive technology. The most significant impact of 6G will be on businesses. So while business models are reshaped, new business lines will emerge. Imagine that. Most probably, I have the same problem as well. Our children's profession yet to be discovered. I'm forcing my kid, 4 years old, but I want him to be an engineer. I'm pretty sure that 20 years later, I don't know what his profession is going to be, because his profession is maybe not invented yet. So with the 6G era, we are going to see new professions, and then everybody is going to, again, as a father, I want him to be an engineer, but I don't know what's going to happen. But to say the truth, that a couple of years back, if you say that it is social media or this kind of new jobs, everybody's still thinking about being a doctor, being an engineer, being a lawyer, but suddenly everything's changed. I'm pretty sure that with the 6G and the new digitalization, everything is going to change faster than today. The impact on sectors and industries will be massive. For instance, the healthcare industry. With the 6G, we are expecting that. Again, I don't want to repeat myself, but when we tried to promote 5G, we were saying the same things. But it didn't happen. So what we need to do is, again, I come back to my first argument, long-term employment. So in the 6G, we need to repeat the same arguments again and again. So right now, ultra-low latency times will transform diagnostics, treatment, wearable technologies, and the biosensor will continuously collect and analyze data, and in order to predict the health issues before they arise. Another example, actually, most important one is the education sector. With the 6G, when we are collecting all this data, so instead of having this kind of conferences, I want to provide this speech, especially for individually single speeches for everyone. So like a hyper-personalization. So instead of watching a movie, or instead of listening a movie, listening a conference, everybody is going to listen to different content, which is going to be provided by all the data collected from your devices. So maybe you don't like my voice, and then when you are listening my voice, because right now everybody listening the same voice. Maybe in the 6G domain, you're going to start listening very different. Maybe you like some singer's voice better, and you're going to put that singer voice onto me, and then you're going to have a special conference, which is you're going to enjoy. So that's going to be a very unique feature for the 6G, especially in the education domain. Maybe, I don't know, everybody likes Hüseyin's voice, but some of your students maybe is going to try to change your voice during your lectures. So overall, the other thing is that with the 6G is going to come is smart cities. And from public transportation to the logistics interface, everything is going to change. 6G will also bring about significant change in the entertainment industry. So overall, live events will be transformed into one-of-a-kind experiences using virtual reality glasses or holographic technologies. As we move into the area of 6G, there will be a significant shift in the manner in which mobile network operators define the services they provide and the roles they play. The transition to 6G represents a fundamental shift in existing operator domain. Connections between individuals have traditionally been the primary focus of our operators all around the world. The end user has been a human for decades. However, we will no longer think of the user as simply the person holding the mobile device. It is more likely that the end user will be the things, such as machines, sensors, artificial intelligence that are integrated into our everyday lives. And that is where the genuine transformation occurs. As operators, we will no longer oversee networks that serve human customers. Rather, we will oversee vast ecosystem of interconnected intelligence. So the leading countries in the 6G technology, which promises such a significant change, continues to invest. And today, we are also, as a government, and all the operators are trying to invest more and more in the next generation wireless communication technologies. Since the first 6G summit in the world took place in Finland in March 2019, there has been a significant amount of progress made in this area of investment. As Turkey is Turkcell, again, what we are going to do? First of all, we are not Turkcell anymore. We called ourselves Turkey is Turkcell. So we just suddenly changed our name, which is not, but as a marketing, I'm always using Turkey is Turkcell, two words. We continue to make investment in the future in accordance with the principle that the best way to be ready for the future is to design it. Again, today, with all these friends and then academy, we want to design it. If we want to be ready for it, definitely we need to design it. So as Turkey's leading technology company, we understand that 2030 is not as far as we expect. And we are already taking steps to prepare for the future. For example, we are the largest data center operator in Turkey. Besides a telecommunication operator, we are a technology firm. And then with all the 6G, with the data that is generated by the 6G, we need to get ready for it. So that's the reason that we are investing heavily on the data center business. Currently, we invest 330 million euros for 4 high-end and high-technology data centers. We will continue to pioneer in the field of data management and security going forward. just as we are today, and we will work towards transforming Turkey into one of the most prominent data warehouse in the world. That's a huge target that we have. We are just going to transform Turkey into one of the most prominent data warehouse in the world. Meanwhile, we have already begun working on quantum technologies. So especially when we talk about the 6G, definitely we need to put a mark on the quantum technologies as well. One of the most cutting edge and profoundly transformative field is the quantum technologies. From the point of view of an operator, quantum technology possesses tremendous potential in terms of the processing of information and the improvement of security. Again, data security is one of our pillars that we work a lot on it. So that's the reason that quantum technology is a must for an operator to work on it and to do research on it. Through the use of quantum computing, we will be able to transform many digital technologies, and quantum encryption will safeguard the massive amount of data destined to pass through our networks during the 6G era. At this point, I would like to add that we will work to ensure that Turkey's development in the field of quantum technologies is in line with our international standards. Another example is on our work on artificial intelligence. Turkcell is a company that recognized the paradigm shift a long time ago. And Turkcell announced its artificial intelligence principles in the year 2019, 5 years back. And any technology that we produce, any artificial intelligence technology that we produce has to obey these our artificial intelligence principles. We have been working and investing in the field for a long time. We continue our investments in 5G collaboration with our public institutions as well as the universities, while at the same time making progress in 6G domain. I will add a parenthesis here for our big project, which is called Turkcell 6Gen Lab, 6G and Artificial Intelligence Laboratory project. This is supported by TÜBİTAK as well, and Hüseyin Hocam also is supporting us in a highly manner. Our 6G generation lab is a way forward for an operator to come up with a technology laboratory to do cutting-edge research. If you look at the people over there, all of them are students or PhD candidates or PhD people. So we have a huge academic. We are working with people who has a strong academic publication record. I'm also proud to announce that we have taken a significant step toward establishing global standards in 6G as a result of our diligent efforts. Within the International Telecommunication Union, ITU, we were the pioneers in the creation of a project group focused on artificial intelligence on telecommunication industry. We also assumed the chairmanship of this platform geared to developing the next generation technologies in the telecommunication industry. This working group is of a critical importance, being the first of its kind on a global scale, and we are going to be the chairman of this group. Its primary objective is to establish artificial intelligence approaches for next generation networks. While we are in the process of leading national pilot projects of 5G and 6G, we are also incorporating elements of digital transformation into the communication technologies of the future. These elements include unmanned vehicles. As you know, 23% of the national car company TOG belongs to Turkcell as well. In Turkish, we call it Baba Yiğit. I don't know how to translate in English, but we are one of the Baba Yiğits of the TOG as well. So smart production systems, we work on it, cybersecurity, and especially big data management is one of our topics that we work very closely with the academia. While 6G technologies present many exciting opportunities, it is also places obligations on manufacturers of the technology. One of the manufacturers of the technology is Turkcell. We must ensure that 6G is deployed in a sustainable and secure manner. Sustainable and secure manner. It is imperative that we establish a network that is both fast and intelligent, but at the same time, as well as reliable. So our investments should be directed towards sustainable energy solutions and security measures that safeguard data privacy. In conclusion, the technology of 6G represents a revolution. and from where we are today, we have the opportunity to shape the future, which currently resembles something out of a science fiction movie. By driving innovation, sustainability, and global collaboration, we can provide unprecedented benefits to the society, to Turkey, and businesses in the 6G era. To conclude, I would like to extend an invitation. Let's collaborate. As I mentioned before, the development of connectivity is not only a narrative of technological progress, but also a story of how innovation is influencing the world we live in. Let's collaborate in the writing of this beautiful story. Thank you very much for listening to me. Evet, sahneye geri döndüm. Hocamdan bir mesaj geldi. Birkaç soru cevap almam isteniyor hocam. İngilizce mi Türkçe mi alayım? İkisi de alır. Aman zor çalışmadığım yerden gelmesin arkadaşlar. Zor soru.
Evet, sorusu olan arkadaşlar varsa.
Oo, çok güzel hocam. Soru yok.
Vardı. Şimdi utanıyorlar da ondan. Arkada bir soru var herhalde.
Hocam geçen sene de aynı arkadaş oradan oturarak aynı soruyu sordu. Geçen sene de. Did you ask a question last year?
Yes.
Because you didn't like my presentation, and then you were asking for more.
It wasn't the issue of the presentation, but you kind
At
of
that time I was
sidestepped on
working for the government, but this time I'm working for a private company.
So I hope.
What's the difference? Is
So-
it okay?
Let's see. So, Dr. Koç, basically what I wanted to ask was, like, if we think about 6G, it's not just something technological that we have to look at, that it's not only the technology that we have to develop. So basically, you also need to look at what kind of services as a telecom provider, basically I'm talking as an operator. So just having base stations and communication technology is not the way to go anymore. Basically, you are, as a business case, you need to provide certain services, which makes everything feasible as an operator. So I wanted to ask, what is the strategy of Turkcell in that regard? Like what kind of, let's say, services that you're looking at, or what kind of mechanisms that you're looking at to make basically, as an operator, this thing feasible for you? Because the other expenses in terms of infrastructure development, that's not reasonable if you're just saying, I want to connect people together. That doesn't make sense anymore.
Yeah. So right now, instead of we are just going to keep on being the best operator overall. So at the end of the day, when the 2G was here, 3G, 4G, and 5G, we are going to provide the best and the greatest technology to our customers as Turkcell. But besides that, as you may say, so we are aware of, all the operators are aware of that there is a limit on the revenue growth. So that's the reason that everybody is trying to figure out different alternatives. So as Turkcell, as the hub because of the geography, we're in a location there where we can be a data hub, or that's the reason I say data warehouse. So trying to make the Turkey as the data hub for the region, taking data from east to west, north to south. So overall, we are investing heavily on the data center business. So as the Turkcell, I'm pretty sure that we can create another Turkcell from a data center business. And it's just in the long run, you're going to see that there's our data center business, our firm which is dealing with the data center is going to be as big as Turkcell. And besides that, the data center business requires a huge amount of energy. So that's the reason that we are looking at a lot of investment on the sustainable energy. Currently, I'm spending $240 million for a 300 megawatt solar energy panels. So I'm going to produce my own sustainable energy to reduce my cost as well as to support my growth. Thank you. How about that? This time the answer is better? Next year we're going to see each other again. All right? That deal. Launch of 6G is, depending on the government, our Minister of Transportation already announced that 6G is going to be in the future. The first part is just a joke. No, the 5G is going to come, but as you may know, every 10 years everybody's saying that 2030 is going to come the 6G. But Turkey is a little bit like 4 to 5 years lagged because we are getting the latest and the greatest technology. So that's the reason that for Turkey, the time is going to be shifted. But there's the rules, and I'm pretty sure that everybody's going to push to saying that in order to be competitive, around the 2030s, everybody's going to come up and say, oh, I have a 6G phone, I have a 6G base station. But the biggest problem is that we are facing right now, especially in the 5G domain as well, the use case. If you don't have the use case, if it is written over there 4, 5, 6, 7, 8, whatever you call it, I can do it with a small software upgrade, I can write it down, whatever you like. But the problem is, what kind of use case that we have to provide the users and our customers the best experience. So that's the reason the experience management is going to be the next big thing, instead of calling a different name on the technology. Last.
Aziz sen sor ondan sonra.
Hemen Aziz Bey, siz sorun dinliyoruz Aziz Bey.
Hoşuma giden bir şey oldu. Siz herkes konuşmasında ilk önce artificial intelligence der, sonrasında kuantum der. Ama siz ilk önce kuantum dediniz, sonra artificial intelligence dediniz. Bu kuantumla ilgili siz computing tarafında mısınız, key distribution tarafında mısınız? Orada bir şey çalışmanız var mı? Bu laboratuvar gibi ya da bir şey gibi.
Tabii ki. Şu anda gerçekten de en son arkadaşlarımızı Amerika IBM'e de gönderdik. Çok güzel bir iletişimimiz de var. Yani biz gerçekten kuantum konusunda leap ahead bir şeyler yapmak istiyoruz. Ama daha fazla konuşmak, bu benim sunumlarımın hepsinde her zaman öndedir. Çünkü artificial intelligence artık belli bir seviyeye gelmiş bir teknoloji ve kullanım odaklı oluyor. Modeller belli, LLM'ler belli ama kuantum daha bakir ve özellikle iletişim anlamında, siber security ve key exchange anlamında yapabileceğimiz şeyler olduğunu düşünüyoruz. Ya daha diğeri özellikle büyük 5 tane büyük dev firmanın hegemonyasına girme üzerine doğru gidiyor. Kuantum daha o seviyede değil. Ondan dolayı eğer siz uzun vadeli bir strateji yapıyorsanız kuantumu önceliklemenizde daha büyük bir fayda olduğunu düşünüyoruz. Evet, last.
Thank you, Dr. Ali. So one question, AI or artificial intelligence has a lot of potential, and we have seen a lot of things happening. So it can make your network more efficient, but do you think that AI potentially can provide also more revenue? Because what you have today, you can get a lot of data from the devices, you have the infrastructure, so what you can have is an edge cloud, where you can potentially process information like inference, you can maybe run some applications, you can collaborate with web scalers, you can even do maybe some split rendering there. So do you think that AI with your distributed architecture could be a source of potentially more revenue for Turkcell?
Yeah, for all the operators are looking for revenue sources. When the digital services first pop up, everybody's saying, oh, because of digital services, all the social media, we're going to make lots of money. Guess what happened? They make the money. We just provide the roads and then the ways of, and then we have to be ready for it. So if this with huge artificial intelligence companies are providing services without any revenue share, we need to get ready for it, and we need to put some space holders like a finger point, so such a way that we are not supposed, we have to be ready for it, and we are not. We need to tell them that enough is enough. So you make lots of money with using our own infrastructure, digital services, and right now with the same thing suddenly trying to be happening. I know. Yeah, all the artificial intelligence search engines, all the LLMs are using our old infrastructure and technology, but they are not sharing any revenue. So in the future, either you are going to be part of it, or you need to be, if competing with them is kind of impossible, because their core business is digital services.
Agree, but maybe you have the power of, you have low latency, you can maybe be close to the radio. If that is becoming relevant, then maybe you have a like position in the ecosystem where you can collaborate and then maybe provide some revenue for
That's a key point, getting closer to the edge or getting closer to the customer. That's our strength. So we need to utilize it and we need to capitalize it. Yes. So we need to make money out of it. Hopefully in the future, I'm pretty sure that there's going to be some revenue sources from that kind of edge computing.
Okay, good.
Thank you very much.
Açıldılar.
Açıldılar mı hocam? Bir tane daha.
Son bir soru daha alalım, tamam kapatalım. Bir mikrofon al istersen.
Oh.
Merhaba, hello.
Merhaba.
Will 6G have an interaction with artificial intelligence, which is AI? Will there be an interaction with AI?
When?
No, will there be interaction with the AI?
Of course, so everything is right now, if, to say the truth, that there's a huge appetite about the AI right now. Even if you are cooking a food, everyone's saying that, AI is supposed to be there. So it is independent of the technology. But to say the truth, that with the 6G, with the enormous of data, definitely there's going to be AI interaction. Because, if you think about it, AI feeds off data. So if important data or meaningful data, quality data is going to provide you a very nice AI algorithm. And if you have a good AI algorithm, you use more, and then you create extra data, and then there's a huge loop. So to say the truth, that with the 6G support and the enormous of data, AI is going to be always there. So we cannot think about it. Right now, even if the 5G, we're always trying to come up with some machine learning algorithms. There are different mimics. So when we need to justify, or we need to clarify what the AI is actually. Whatever you are doing is, currently they are doing some small software and they are calling it AI. It is not a real AI. We need to talk about the generative AI part a little more. But currently, all the machine learning or the rule-based AI algorithms are going to be everywhere, 5G and 6G. But we need to think about it still a little bit more about how the generative AI is going to fit into the telecommunication industry. All right. Thank you very much. I think I need to catch a flight. So thank you very much for listening. Thank you.
Sayın Doktor Ali Taha Koç Beyefendi'ye yaptığı konuşmasından dolayı teşekkürlerimizi sunuyoruz. Şimdi hediyelerini takdim etmek üzere Profesör Doktor Hüseyin Arslan hocamızı sahneye davet ediyoruz. Şimdi konuşmasını yapmak üzere Nokia kıdemli danışmanı Doktor Harri Holma Beyefendi'yi sahneye davet ediyoruz.
Okay, let me check it works. Hey, yes, good afternoon, and thank you, Dr. Ali, for the great talk today. Thank you also for the Professor Arslan for the invitation here. So the idea for my talk here was to look at a little bit more details what 6G means in terms of technology, what we need to do in the underlying networks, what we need to do in the underlying technology to make it 6G ready. And my name is Harri Holma. I'm part of Nokia technology office. I'm based in Nokia headquarters in Finland, and happy to be here today with you today. And the title I have put here is From 5G Learnings to 6G Design Targets. So the idea is kind of like, let's try to learn what has been working fine in 5G and what has been maybe not so fine in 5G, and use all these learnings to make a 6G network even better than what we have currently. One topic I wanted to start here is to show that what 5G has been successful today is boosting the radio performance. So if we simply look at where the radio has been before 5G and where the radio capability or the radio performance is after 5G, you can see a massive boost in performance. And this data here is crowdsourced data. So this data is collected from normal people devices, and what I'm showing here is two things. First, we are showing the improvement in the data rate on the left side. And I have taken here 3 example markets. One is India. Well, India is a big market. Then one is France, like an example, European market. And then Nordic countries, which is Finland, Sweden, Norway, and Denmark. And what we are showing here is that 5G connectivity is improving the practical user data rate massively. The typical data rate customers are getting like 250 to 300 megabits per second. And if you look at the measure today in Turkey, is 28 megabits. So clearly my expectation is that when 5G will be deployed here shortly, there will be a major boost in the practical user data rate. Now, of course, we can be asking that who would need 200 or 300 megabits per second? Now, remember that if you look at the right side of this figure, is indicating that there is also a boost in the user experience, and the example here is video. Remember that video is the most typical application customers are using today, and you can see that the video quality is improving also massively. What we are showing here is so-called video experience score, and you can see that 5G customers today can enjoy substantially better video quality than 4G customers. So very simply, great radio performance in 5G, much higher data rate, and also in practice, clearly better application quality, like video quality. Also, I wanted to show specifically India market because the development in India has been impressive, and we are also showing here crowdsourced data, and we are showing the average customer data rate in India and a few other markets. And now remember that India started 5G commercially roughly 2 years ago. It was September 2022 when 5G was starting. And at that time, the average data rate for the Indian customers was below 20 megabits per second. And now just 1 year later, September 23, it was already getting close to 100 megabits per second. And now 2 years later, the average data rate in India is roughly 100 megabits per second. Isn't that impressive? In 2 years' time, from less than 20 megabits to more than 100 megabits per second. And right now, India is actually on the same level as some of the advanced markets like US or Nordics, getting close to Korean performance. And actually, India today, in terms of data rate, is even better than many of the European markets. It's better than Germany, better than UK, for example. So it means that 5G technology and a rapid rollout like in India can provide a substantial boost in the performance there. And now, of course, you can be asking that, do we actually need such high data rate? And besides smartphone applications, there is one specific use case where the 5G has turned out to be quite successful, and that is so-called fixed wireless access. The idea is that when 5G data rate is so high, why don't we use the same 5G also for the home broadband connectivity? Not only smartphones, but home broadband, yes. And it has turned out to be a successful service. What we are showing here is the number of fixed wireless access subscribers in US, and today is more than 10 million by mainly T-Mobile and Verizon. And customers like it because it's so simple. You can get the home broadband connectivity immediately, and also it's providing a lot of revenue. So the US operators today are getting more than $10 billion per year additional revenue out of fixed wireless access service. What T-Mobile has been indicating until last week was that they expected that they can support 7 to 8 million fixed customers in their 5G network. That was their estimate, 7 to 8 million. Now, last week, T-Mobile was hosting a capital market day for the investors, and they upgraded their target. Now, T-Mobile is indicating that they believe that they can support even 12 million fixed wireless access subscribers in their network, which is an impressive number. And that means that also for Turkey, there would be a lot of potential here in this example, home broadband connectivity service when the 5G will be available. Then, of course, 5G can provide also impressive data rate. I did some simple speed testing with my device back at home in Helsinki, and if I'm close to the 5G antenna, I can get more than 2 gigabits data rate in downlink and more than 100 megabit in uplink. And I would expect that this kind of data rate should be also feasible in the local market here once the 5G spectrum will be allocated. And one example how to utilize that extreme data rate is, of course, high capacity. 2 gigabits per second is too much for one person, but 2 gigabits per second means that you can support even 100 heavy fixed customers, like 100 homes, and on top of that you can support 1,000 smartphone customers as well. So high data rate means also high capacity for multiple different services. But 5G is not only about data rate and capacity. 5G is also about providing different treatment and different slices for different enterprises, for different applications. So clearly slicing is now becoming one of the new great sources of revenue for the mobile operators. And I'm showing here a slide by T-Mobile, because T-Mobile has been also quite advanced in terms of using their 5G network for slicing. And now you're asking, what are the example slices? What are the use cases that slicing can be utilized? And interestingly, the most important one seems to be security. SASE, Secure Access Service Edge, where the idea is that you can kind of like provide VPN, virtual private network type of service on your mobile connectivity. And for that, you can provide a dedicated slice out of your 5G network. Another example what T-Mobile has been doing successfully is to provide dedicated slice for the payment machines and for the ticketing machines. Because if you look at like some big events, you want to guarantee that the payment machines are working. And that is what slicing can provide. A third example is video streaming and uplink, because there are some broadcast companies that want to use 5G network for sending live video in uplink. And for that, they want to have certain guaranteed uplink bandwidth. And that is exactly what slicing can provide. And now there are also even further ideas to work with the application developers to utilize slicing also for the lot more different use cases. Now the other topic that is now becoming more important is also uplink performance. So we have seen that there are more and more applications like enterprises where better uplink performance is becoming important. We want to have more uplink capacity, we want to have higher uplink data rate. And the latest development in 5G has also turned out to be useful for providing better uplink performance. And what I'm showing here is example drive test results by an independent company showing how the uplink average data rate can be enhanced with 2 technologies. And these 2 technologies are carrier aggregation and 2x2 MIMO. And you can see that compared to having only one band, FDD or TDD band, you can get a major boost in your uplink performance when combining 2 antenna transmission and carrier aggregation. And I think that there is indeed a major need for the better uplink, because if you compare fixed network and if you compare mobile network, today the mobile network downlink performance is kind of pretty okay, but the mobile network uplink performance is quite low. So clearly there is a demand to make uplink better, and there are also now technologies which can make uplink better. Another important topic now happening in 5G today is so-called REDCap, reduced capability, IoT optimization, where the idea is that let's make a new type of 5G device where the capabilities are in the order of 100 megabits per second. You can do even video, you can do many enterprise applications, but where the cost and the price is substantially lower than the full-blown 5G. And that is the idea of REDCap. You can still provide high enough data rate, but the power consumption and the cost will be less than for the full-blown 5G. And that is now starting commercially this year, and that is defined in 3GPP releases 17 and 18, and that will work with a standalone architecture. But there's a lot more also what 5G can provide, what we have not seen today, and that is actually called 5G Advanced. So in terms of 5G Advanced, there are a number of things where we want to focus and what we want to make better. And in Nokia, we want to distribute this into 3 areas. We want to make better customer experience, Secondly, we want to improve the network operability. And third, we want to enable new use cases. And the experience is example uplink performance like we discussed. Another one is we want to minimize latency. We want to make the network better, able to support extended reality, XR type of traffic. Secondly, on the operability, we want to take the first phase of AI into 5G network. And also we want to minimize the energy consumption of the 5G mobile network. Of course, key topics there. And for the new use cases, we are working on new type of devices like RedCap device. We want to do drone optimization. And also we want to integrate the satellite connectivity. So the idea is that you can use the very same 5G or 4G device for connecting to your terrestrial network here locally and connecting to your satellite network as well for the extreme coverage cases. And now one example what we have been doing, for example, on the customer experience area or the latency area is a solution called low latency, low loss. It's also called L4S. And that is an innovation that has been done by the Nokia Bell Labs originally. And we have already implemented the first version into our Nokia 5G radio network. And the idea in the L4S is that the radio network can indicate to the application that congestion is about to happen. And in that signaling, the application can lower the data rate. So the cool idea here is that before congestion is causing buffering and before congestion is causing extra delay, the application can lower the data rate and maintain low latency. And that is why it's called low latency, low loss. No packet losses, no latency increases. And it is actually showing quite nice performance. You can maintain the video quality even during the congestion in these specific cases. But let's look at also what 6G potentially could do. So a lot of things 5G can be doing, but we want to make 6G radio a lot better. And I wanted to start the 6G discussion here first by looking the radio spectrum options, because if we want to get more bandwidth, if we want to get more data rate, more capacity, we also need to get some new spectrum blocks. And the global spectrum allocation is discussed in the World Radio Communication Conference called WRC. That will meet every 4 years, and the last WRC meeting was concluded in December 23. And the outcome of the last WRC was actually quite positive for the 6G spectrum. There are now some spectrum blocks to be studied, potential for the 6G allocation. And the most important one is between 7.1 and 8.4 gigahertz. And if the study is positive and if the study looks nice, then potentially in the next World Radio Conference 2027, the spectrum could be identified for the IMT use for the 6G. Another important spectrum block is between 6.4 and 7.1, that is so-called upper 6 GHz band, which already today has been identified for the IMT use in some regions as well. And then also we believe that refarming will be important. So we want to make 6G design in such a way that any 5G network today can be turned into 6G on the existing frequencies. So smooth, dynamic refarming of 5G to 6G and some additional new spectrum around 7 GHz band. And now what can we do if we can get 7 GHz band available? What does it mean from the radio point of view? And then we have done some studies on the 7 GHz band antenna design and simulations, and the outcome is that you can actually enable a lot more data rate, a lot more capacity. And what we are showing here is the history. Remember, LTE 4G today is typically having 4 antennas and it's 20 MHz bandwidth. 5G is up to 64 TRXs, beamforming antenna, and up to 100 MHz bandwidth. and that can provide a lot more capacity. Now 6G potentially could use even more spectrum, potentially 400 megahertz bandwidth, and also using even more advanced antennas, like maybe 500, 700, 1000 TRXs. And now the combination here, more bandwidth and even more advanced antennas can provide even 20 times more capacity. So the idea here is that 6G will be the solution how to provide a lot more bandwidth for the traffic growth beyond 2030. And how is that possible now technically? Remember that if you look at the beamforming antenna, like massive MIMO antenna, you can see some prototypes here in the demo area. The typical antenna today is having 128 or 192 antenna elements, and these are on 3.5 gigahertz band. But now when your spectrum or the frequency increases, your wavelength is getting smaller. And remember that the antenna element spacing is always relative to the wavelength. When you double your frequency, your antenna element spacing will be 50% smaller, which means that you can have 4 times more antenna elements in the same area. Which means that if you have an antenna of 192 antenna elements today, and you double your frequency, then you can have 768 antenna elements in the same physical area. The same size of antenna, no increase in the antenna size, 4 times more antenna elements. And now the benefit here is that you can make the antenna gain higher. You can have even 6 dB higher antenna gain, providing better link budget. And secondly, you can make your beams even more narrow, which means that you can minimize interference, you can maximize the cell capacity. That is of course not easy. I mean, in order to implement beamforming antenna with 768 antenna elements is a complex thing, and therefore a lot of R&D, a lot of hardware development, a lot of software development will be needed for that. And in order to make it happen in the future, we already have started to do some testing. So what we are showing here is a base station site in Helsinki, close to Nokia headquarters, and we are already having a prototype antenna on 7 gigahertz. We have the commercial 3.5 gigahertz antenna here, and then we have the 7 gigahertz antenna. And the 7 gigahertz antenna has indeed 768 antenna elements, so 4 times more antenna elements. And what we are now running is field measurements to identify the cell radius, identify the propagation, also try to optimize the beamforming. So the message here is that we are already starting the work to make the 6G extreme massive MIMO antenna happen. But 6G is also a lot more. It's not only new spectrum, new antenna. I tried to collect here 6 key new features which are different than what we have in 5G today. So what are the key technical topics in 6G? Extreme massive MIMO antenna we already discussed, but the second topic is clearly integration of artificial intelligence into radio. And we believe that by properly using AI in the radio design, you can make the radio performance better. You can make the throughput better, you can make the capacity better, you can even make your coverage better. Thirdly, actually, we want to also make uplink better. We believe that there are still technologies how to make the uplink data rate and uplink coverage better than what we have in 5G today. We also want to make the energy efficiency better, not only keeping the energy consumption on the same level as today, but actually making the energy consumption even lower than today while providing a lot more capacity. It's a high target, but there is potential to do it. We also want to integrate sensing into 6G radio, where the idea is that 6G radio is working as a communication device like 5G today, but 6G radio could also work as a radar, as a sensing device at the same time. So one radio working for communication and for sensing, potentially for more revenue, more use cases. And then finally, 6G will be designed for new type of devices. Like maybe some XR devices will take off massively 2030. We want to make it fully XR optimized. Ambient IoT is one topic, very low cost, low power consumption, IoT device without any batteries, satellite communication maybe, a lot of new type of devices. So you can see that there are many things which are making performance better, making efficiency better. And if people are asking, do we actually need to have 6G? And I would say, yes, of course we need to have better energy efficiency. We need to have better uplink. We want to integrate AI. So these are exactly the topics that the 6G design is about. And of course, integrating AI to radio is not simple, and that is why we have started the work already today. And there are some examples what Nokia is doing today to understand better how to utilize AI in the 6G radio. And first of all, we are working with a number of companies like Docomo and SK Telecom in Korea. We are working on the 6G AI native ear interface, where the idea is that the ear interface design would not be fixed, but there would be some flexibility for the AI-based instantaneous adaptation. And now, of course, you can point out that isn't that going to be quite difficult if the base station has its own AI and the devices will have its own AI. How are these two things going to interwork? And that is exactly what we have been working with Qualcomm. So we are trying to understand how the AI in the device and the AI in the base station will interact together. We actually have done some field testing with the Qualcomm chipset and Nokia base station to understand these challenges. And then third point here is that we are also testing integrated communication and sensing. This test case is in the Arena 2036 in Germany together with Bosch and some other partners as well. Another topic that we are doing in AI is collaboration, because clearly, like indicated by Dr. Ali, we need to have collaboration, and therefore Nokia and some other companies started AI Run Alliance earlier this year. And the idea here is to have industry alliance which is driving AI research and innovation for the radio networks. So the idea here is that let's use AI for making the radio better, but let's also consider how to integrate AI applications on top of radio. And also third point here is that let's consider how radio and AI processing could be sharing same resources. And now last week there was also an important press release between Nokia, NVIDIA and T-Mobile, where we announced that we are now starting a joint innovation center in US to make this AI run happen. So how to integrate AI and cloud and radio access network together. So we want to have the best companies as part of this works. We have T-Mobile, we have NVIDIA, and we have Nokia, and we have also Ericsson as part of that. Another one we have is also similar kind of collaboration with SoftBank from Japan. And then if you look at finally timing, where are we today and where 6G will be then ready, then I drafted here the 3GPP standardization timeline. We are now here in September 2024, and 3GPP will be starting the work for 6G specification in March next year. So March 2025 will be the starting point. Study item will be part of release 20, and the actual detailed work item will be part of release 21 2027. And the expectation today is that the first version of the specification will be ready by 2029, which means that the commercial launches may happen 29 or 2030. So these would be the first global commercial launches, which by the way is exactly 10 years after 5G. Remember that the first 5G started 2019, and now we expect that the first 6G potentially would be starting 2029. Now we also discussed here bandwidth, and I'm showing here the mobile data consumption. So this is kind of showing that how much bandwidth and how much data mobile customers are using in different countries. And the data volume here is showing how many gigabytes per SIM card per month is being utilized. And that is starting from 2017 until 2023. And of course, first of all, you can see that people are using more and more data. So clearly we need to have more efficient radio, we need to have 5G and eventually 6G to carry this data growth. If you also look at Turkey, the data consumption is fairly high, is on the average level, but potentially with the 5G radio, there would be room for even more data consumption. And if you look at the highest countries here, Finland used to be number one, but now unfortunately Saudi Arabia has become number one in terms of data consumption since last year, which means that in Finland we need to try to use more data, and at least personally, I have been trying to use as much mobile data as possible. And before I came here to Turkey, I was looking my mobile data consumption during September. So from September 1st to September, I think 18th, in about 2 weeks' time, my personal mobile data consumption was more than 1 terabyte of data. So clearly, I'm trying to boost the mobile data consumption here. So I would like to thank you for your attention today here. I hope you learned something, and I guess we have also time for some questions here before the next presentation. So thank you.
User equipment side, you talk about the cell improvement nearly 20 times. The UEs can get the same increase because it's easy for a cell. You have enough power, you have lots of antennas, but from the UE side, how can we achieve these throughputs?
So good question about the uplink performance. So I would say there are two things. The first thing which is important here is refarming. It's clear that 7 GHz spectrum alone will not provide 100% coverage. 7 GHz is not for the deep indoor. Therefore, one important component in 6G will be fast and efficient refarming, which we call multi-radio spectrum sharing. So we want to bring 6G radio to the 5G frequencies without changing the RF. So fast, efficient refarming. That is number one. And the second point is that we believe that there are still technologies how you can make the uplink link budget better. I was saying maybe 4 dB, maybe 3 dB, by some waveform optimization, by some duplex arrangement. So I would say that is a combination here. Let's make a link budget a little bit better with the latest technologies. And secondly, let's bring 6G also to low frequencies in addition to the new frequencies as well.
Thank you.
Thanks, Henry. A very interesting talk. I mean, I wanted to ask you that when we talk about these receiver architectures for AI native air interface, generally you include some sort of GPU for processing on the receiver, for example. Do you think that trend will push the energy consumption on the UE side quite high from where it is today?
That is a good point. So if you look at first on the network side, I mean, we are working with NVIDIA. We understand the challenges there. We also have our own, if you look at the Nokia base station design today, we have the SoCs where we have integrated AI processing. Now for the device, I don't think I have any kind of clever or intelligent comments here. So I think in the devices, power consumption is critical, and therefore we should minimize kind of excessive complexity for the devices to keep the power consumption low. So I think that is one of the research topics here. I don't think anybody has a clear answer on that specific question today. So.
Hello, my name is Salahdin from Ula Kavalleşme. Thanks for the presentation. My question is, you know that with the increase of time, the data traffic is increasing, and what we are trying to do is to cope up with this. Therefore, we are introducing new technologies to increase the data rates by adding multiple antennas as a transmitter receiver, finding new different spectrums for larger bandwidth. The thing is with 6G that I see different from 5G is that not only the number of users is increasing, but 6G now is embracing different technologies. I can give you an example for that. We used to have dedicated short-range communication between vehicles. Now we are bringing V2V to 6G, to cellular system. We used to have IoT system, separate technology. Now we are bringing NR technology, IoT NR. We also have the NTN, non-terrestrial networks. We are also trying to adopt it with the same network. So by adopting all these technologies with a huge number now of devices, is the current solutions enough to cope up with all the change now?
I think that is a good question, and you can see that many things are already happening in 5G today, like V2X is in the early phase. You can see like 4G and 5G being used for the public safety, for example. 4G and 5G being utilized for the train control. So part of that is already happening today in 5G, but 6G, I agree, should be even more. And the target has been that we want to make sure that the first day design in 6G is considering these cases, because you see that the problem is that if you want to later bring some new use case into the radio, has turned out to be difficult. Like NTN, non-terrestrial network, was an add-on feature in 5G. In 6G, we want to make sure that every device from day one is designed for that. Another one is low-cost IoT. We want to make sure that there are no bottlenecks in the 6G design that will later prevent using those solutions. So it's more about that making the day one design and the day one devices so that it will allow and enable later any kind of new connectivity implementation as well.
Last question.
Thank you very much for the fruitful discussion and updates about the employment of 6G. My name is Tariq Adnan from Karabuk University. Actually, I have a question that it's envisioned in the future communications that transmitters adapting themselves to the channel between transmitter and receiver so that they're gonna adjust the parameters of the signal so to optimize actually best transmission, and this will exempt them of sending very crucial data to the receiver, which normally this data is used to recover the data, the received data. So we are like building some intelligent receivers. My question is there any initiative taken by Nokia to work this kind of technology, building intelligent receivers, we can say?
Yeah, that is a very relevant topic, and there are a lot of papers Nokia has published on that topic. I can give you references, and maybe you can find it's called Deep RX. So Deep Learning RX or Deep Learning TX is the title. You can find in the IEEE webpage, and we have done also implementation in the NVIDIA GPU on top of simulations, and the idea indeed has been that we are adapting the transmission and the receiver based on the AI. But I'm happy to share that, and maybe you can find also that information. That is, of course, one part of the AI Run Alliance, this kind of studies as well. So thank you.
Thank you.
Yeah, good, thank you.
Sayın Doktor Harri Holma beyefendiye yaptığı konuşmasından dolayı teşekkür ediyoruz. We are so appreciated for the Dr. Harri Holma for his speech. Şimdi hediyelerini takdim etmek üzere Profesör Doktor Hüseyin Arslan'ı sahneye davet ediyoruz. Now I am inviting to Professor Dr. Hüseyin Arslan for the giving this speech. Şimdi konuşmasını yapmak üzere Ediburgh Napier Üniversitesi'nden Profesör Doktor Berk Canberk'i sahneye davet ediyoruz.
Okay. Thank you very much, and good afternoon, everyone. After these two fantastic talks, mostly focused on the industry, I think I am the one who's gonna close this session as a bit like an academic perspective. So please be with me. I mean, try to do your best. It's gonna be like 35, 40 minutes full of research questions, contributions, and those kind of things. And before starting my talk, I wanna thank all the Medipol University team for this fantastic organization, and especially my dear colleague, Hüseyin Hocam, for his invitation. Okay, today I'm gonna talk about digital twin and how we can merge digital twin for 6G. My name is Berk, and I'm a professor in Edinburgh Napier University. Edinburgh is a lovely city. Of course, I am from Istanbul, not as much as Istanbul, but it's quite a lovely city. If you have time, you can visit Edinburgh. Another hat that I have, and I'm really proud of, that I am the Research and Innovation Director of BTS Group, which is the biggest network automation company in Turkey. And as you can see, I mean, the most important part of the slide is the rightmost part of the slide, the real heroes of the work that I'm gonna try to show. They are all being sponsored and having scholarship from BTS. Some of them are in Edinburgh with me. Some of them are in ITU. I also have the affiliation with my previous university. I still hold that affiliation with Istanbul Technical University. And I have like a visiting position, but it's not, I'm just going not too much. You can see some figures there. I will not go into detail about those figures. As I say, you are going to see lots of research that we are focusing on digital twinning. We have also a digital twin platform that we managed to build back in Edinburgh, thanks to the BTS Group's real-time server that we are connecting in real time. I will show all of this in the next 30 minutes as much as I can. Okay, I know you know what is digital twin, but just pretend that you don't. Digital twin is the physical replica of a physical object. Previously, when I started this topic like 3-4 years ago, I was telling to the audience when I have a speech that, okay, you can Google it and you can find it out, but now I convert this sentence as you can check GPT and you will find better results than we have here. But all of them rely on the fact that we have like a physical process which is going on, and then you need to have the replica of this process in another environment while the physical things is going on. This is the basic difference between a simulation and emulation. I'm sure you have questions about this. What is the difference between the simulation environment and the digital twin? Huge difference, completely different. But we are ready for those questions because it's been asking for several years. So the main difference that we have is that you have a physical aspect and you have a virtual replica of the physical aspect. Okay? And I will show you in a couple of slides later on. So you will have two screens, like twin, and then one screen you are going to see what is in reality, and in the second screen you can get crazy. You can do whatever you want, but you have to keep your eye with the reality. So this is the difference. Okay, here you see three pictures. On the leftmost side, we were also together with Hüseyin Hocam there. It was in Kuala Lumpur. I mean, don't look at me, I'm not important, but the background, there is this lovely Petronas Tower, which is really real twin. You remember of this picture, you are the one who took it. So in that picture, you see the real twin. This is not the one that we are talking about, because in that one, so they don't have any interaction. They can, but this is not official. The second one, the famous Avatar movie, this was one of the reviewers that the review that I got several years ago when I first wrote my digital twin paper, saying that Avatar is a digital twin, but in your case, you try to do blah, blah, blah, which is wrong. Avatar is a virtual reality. Why? Or an augmented reality if you want. Why? In the real life, the guy is laying down. Okay? But in the virtual life, he's a hero. He does some stuff that you cannot control. But in the real life, he doesn't do those things. So it's another approach. is another thing. You can have different terminologies, like we have digital shadow, digital model, digital whatever, but this is not the digital twin that we are academically talking about. On the rightmost side, you have the NASA picture. Actually, there they are doing like a real-time replica of a real rocket, the real thing that they are actually going up. Of course, not in the real scale, in a small scale, but they are actually monitoring what is in the reality. Okay, so this is some kind of an approach that we are trying to come up while we are talking about a digital twin. This thing. Remember I talked about two screens, right? On the leftmost side, you have all the real-time monitoring. We all know there is no something new. But on the right-hand side, according to the real-time monitoring that you have, you can have different types of simulations, optimization, what-if analysis, recommendation engines. Of course, we are going to use AI. This is the topic, as we all know. So we try to grab some data, and we try to mimic the reality, and we try to come up with new simulation environment or new recommendations or some kind of real statistics. Okay. This is the digital twin that we are talking about. Okay, so we try to combine the reality with the simulation environment. And what we are doing as an academic in my lab, we try to write all the process, all the communication process. I'm a communication person in reality. I'm not in the simulation I was not in the simulation environment, but with digital twin, we are also focusing on the simulation things, but not in 3D, 4D. But we try to like connect all this real-time communication with as low as possible latency, with as low as possible jitter, etc. So this is the whole idea. So as you can see from this figure, so in the simulation environment, you see that in the simulation you can have the question, what may happen in the system? Whereas in the digital twin environment, you see what is actually happening. This is the catch, okay? We have some different metrics with us. We don't usually do the metrics like usual jitter and delay. We have, for example, real-time data rendering. Let me read it from here, it's better. Like two-way communication, which is actually one thing that we are really proud of because it's the main catch of digital twin. We are not talking about the first way, but we are talking about the two-way communication. We also have, actually this is patent with BTS, twinning rate and the twin fidelity. The idea is that we try to mimic the reality as much as we can. But this is difficult because the reality keeps going on. You have to catch the data with low complexity, with low latency, and try to do this online AI, try to mimic the reality, and then forecast. So this is quite challenging for us. We have another patent, like patent parameter, like age of twin or polymetric twinning index. Those are all different types of metrics that we are using. I told you it's a bit academic. So this is the market size. I mean, we all know that digital twin is going to a level that goes really, really high. And we are sure that up to 2030 is going to be really somehow replacing the IoT. I mean, not exactly, but we will have some showing that it's gonna replace. We have lots of industry, like manufacturing, agriculture, automotive, energy, healthcare, so on and so forth. And with those industries, I mean, anyone who has his own data, like capturing lots of data and try to do something with the data, push themselves to do digital twinning because they want to monitor their environment in real time, and they want to do some kind of forecasting, but online forecasting. They want to do some recommendations, or they don't want to do anything right now, but they want to estimate the future. For example, I'm going to show like a slide, maybe in 10 minutes, that you probably know Scotland is really famous with his wind, so we have a really huge wind, so we try to come up with where to put new wind farms. So wind farm doesn't exist there, but according to the online data we are gathering, like meteorological data and all the topological data, if we put a new wind farm somewhere here, the efficiency will be really high. So what type of new and forecasting process that we can put? So this is also under the umbrella of digital twinning. So where is AI here? AI here is the brain or the cognitive engine of a digital twin system. So what AI enables? AI enables, like you can see, intelligent data processing, accurate and proactive modeling. Proactive here is really important. This makes things challenging for us because you have to be quick. You don't have to collect all the data. You have to smartly filter the data, like pre-processing data, so on and so forth. So you can have cognitive data querying. Another issue with us, if you keep using the normal, languages, data languages that we know, the storage of those data will be quite limited for you, so you have to come up with different perspectives. Of course, in what-if scenarios or in scenario optimization, in all those things, the AI is our friend. So we are not, as a group, we are not here to build up new AI algorithms, but we are somehow using the algorithms in order to be suitable for this real-time digital twin environment. This is the good thing that we try to do. Okay, now buckle up. We have like 8-9 slides with the current research that we are doing. I will be as quick as possible. So the RQ that you see is the research question, why we do this, and how we do this. So I will, as I said, I will be quite quick. And there are lots of collaborators with us, our partner BTS and the other collaborators. For example, the one that you are seeing here in this slide, it's a particular real-time protocol that we build it up in order to make like this digital twin communication possible. Remember the chain that I showed you? This is one of the practical things we did. It's also a continuation of a Royal Society project that we got 3 years ago. And the main idea, the research question that we were asking is that how to serve a two-way and fully synchronized digital twin communication in IoT systems. Here, IoT, or you will see vehicular communication, you will see urban communication, you will see several things. These are all use cases for us. We try to come up with the holistic approach, which is really difficult. We are still some way to go. But we are trying to reshape the protocol stack that is already existing. As you see in the rightmost side of the slide, we have like a protocol sequential diagram. If you are a computer engineer, you know that this kind of sequential diagram are drawn in automata theory lectures. This is one that I also give. So using this kind of automata theory that we have in the field, we try to design in a complete new manner the real-time digital twin protocol as a stack. Another one, in order to attack the accuracy and the timeless. What is the research question? How to effectively synchronize digital twin. It's a huge issue. Synchronization, I know, with Fiyocan, know she's also with me in all this different type of communication challenges. Synchronization is a real issue for us. I mean, even back in my PhD time, I was dealing with those things. But again, he's with us. How? We try to synchronize the reality, the first screen, with the second screen. Because you can monitor perfectly, and you can mimic it perfectly, but while you mimic this one, this guy can go away. So you have to synchronize in a better way. How to tackle this issue in a digital twin system? There are lots of maths going on, and this time, of course, BTS with us, Türk Telekom also with us in order to have this papers and the project. We are trying to come up machine learning generated aspect to attack accuracy and timeliness. Another project that is recently we got acceptance and we have started It's EU-funded 6G BRICS together with Turkcell. So here we try to do the digital twin of the Open RAN simulation environment, and we try to create a scalable virtual test environment for 6G RAN. So we have some time to do that, but we already have a platform. I will also show this platform in a couple of minutes. Using that platform, we are going to have some kind of Open RAN-based emulation to make it more realistic. Another one, this time, next generation transportation network as a use case, so the cars and the roads. The idea, the research question is that how to lower emissions on road transportation networks by controlling the traffic flow. So we were trying to control the data flow in order to lower the energy of a router. Now delete those the keywords and then put the one that is true for the transportation. Another new topic came into the scene. And here we try to come up with transport-specific twin sampling. And then we are going to try to do the sampling rate as low as possible. And this project is also get funded by, we are going to promote this to the digital twin like an excellence center that is already launched in EU portal. This is another one. Digital twin enabled, this time, connected vehicle networks, not the road, but the vehicles themselves. So the idea is the same. Try to gather the data. If you can gather the data, good for you. If you cannot gather the online data, try to mimic with the one that you have in your hand, okay, as accurate as possible, and then make it as a data stream, and then come with a digital twin perspective. The research question here is which is the best deployment framework for vehicular digital twins. It can be in the cloud, it can be in the edge, or it can be in hybrid. Which is the best way? What are the challenges with us? What are the trade-offs, etc. This is like back in 4 or 5 years. It started with a TÜBİTAK project, like as a drone project, try to monitor the surrounding and like a flying base station. And then we converted it with our servers in Maslak BTS lab. We converted it to a digital twin aspect. How? So as you see a laptop there, this is the digital twin actually. So we are in the ITU stadium back in Istanbul, Maslak campus, and then we are making the drones fly. And then these drones, they communicate among themselves, like there are more than 2. They communicate among themselves, and then according to their energy, according to their coverage area that they can count, they try to optimize themselves. Who decides for this? This laptop that you see, right? Okay. So this is a digital twin. So it gathers the information from those flying base station. And according to those information, it tries to balance the attitude, even the speed, the tilt angle, and all different types of aeronautical aspects. So this is another approach that we are really, we spend a lot of time, but I think it worth it because if we got it is one of the first best paper award in the digital twin area in academia. We got it in ICC 2024 in Denver, among like several thousands of papers. So the idea is that the research question is that how to develop a robust, explainable AI for attack detection, for a digital twin with a use case of attack detection. So it was a security-based approach. So we try to gather the security data and come up a complete new methodology for the explainable AI to alert people before even this attack has happened. So we had really good results, but we spent a lot of time on that. And then now we are having actually an attack detection, an attack protection project accordingly. This is the network digital twin, part of our group. You remember this, lots of people that we have. Some of them are particularly focused on network digital twin and the performance analysis. So the idea is how to evaluate the performance because of the lack of standardized performance metrics. So I am pushing myself to our platform, and here we have a video. I don't know it's gonna run, but I can explain you quickly because it's Murphy. Whenever you want it to run, it's not gonna run. So I have it in my mind. So this is the real-time core network selection for planes, high-altitude platforms, tested in our digital twin as a service platform. So the idea is quite simple. We all who is going from A to B by plane, we want to use the internet connectivity using in the plane when we are in the cruise level at least. But the data rate that we are receiving obviously is quite low. What can we do in order to increase this without touching to the real world? But how can we increase this data rate in a software manner? And digital twin is a solution for this. Why? We can use some kind of a clustering methodology for this plane, and then tell them that, okay, in the next 5 minutes from now, the planes in that cluster area can use this antenna because they have several antennas, including the satellite antenna, including a ground antenna, or from plane to plane antenna. So we are just recommending them to force them to use a particular antenna or particular bandwidth in order to increase the in-flight connectivity. This is the whole idea. Here we have the simulation environment. The data, it's free. We got the data for free from a website. We use it as a data streaming. It's also a work package for us because it was not that easy to do that. And then we tried to come up with an online and real-time clustering methodology to cluster the plane, because as you know, they are quite fast, obviously. And if you cluster them for a minute, in the next 5 minutes, it can go to another cluster. So you have to be really careful about this clustering, about this online monitoring. But we got some Azure support here, but with BTS servers and with Azure, we managed to get some kind of a nice platform. Actually, it's working. So as you see, these clusters here in the figure, so they are moving. In the leftmost side, you see I don't know if you can see it clearly, but this is the UK map, and at the time of this video recording, these are the real location of the plane, all the planes, and then we are getting those information, and according to the altitude, speed, bearing, and different types of features, we are doing this clustering in an online manner. The same with air quality, the Royal Society project that we have. Here we have how to manage the distributed sensors with different formats for efficient air quality monitoring. We gather the data, and then after gathering the data, we are just monitoring the data in real time and try to come up with a complete new recommendation engine. We don't just gather the data, we implement this. If you are in the network area, probably you know a particular Young-based model, a particular data model for a better tree structure. Anyhow, so we, in order to make things quicker and better for us and more effective, to come up with this air quality-based digital twin. This is interesting. So we have precise ship maneuvering for efficient naval operations. So this is all done in simulation environment. We didn't, I'm really waiting for the implementation. We have ITU with us in terms of the naval operations, obviously. So they are providing all this know-how in terms of how a ship can approach to the port, what are the things, what are the effective things that can happen, what are the dangerous things that can happen. And we try to come up the whole architecture for this efficient naval operation ship maneuvering. And this is the anomaly detection for autonomous networks. This was one of the first projects that we have been through, it was 4 years ago with BTS as well. So as you see the Turkey's map, in those Turkey map, you have routers, and according to those routers, they are real or unreal. This doesn't matter for us. I mean, the locations doesn't matter. The important thing is to grabbing data effectively and as fast as possible, and how we can detect distributed denial of service attacks according to those data that we are gathering in the core network without coming to the edge. Before passing to my last part, which is the platform, this is the research that we have been through. So there is no concrete outcome that I can show in that sense, but we have lots of, as you can imagine, applications and all those proposals already gone through about how we can implement quantum enhanced digital twin. So instead of using graph database that we are using now, instead of using like ordinary AI mechanism that we are already using now, what about implementing all this quantum mechanism here? It's a huge issue, so we need collaborations for that, but we came up to a point. Okay, this is the lab. This is my lab back in Edinburgh, and again, don't look at me. These three ladies that we have, they are all coming from Turkey. They are doing their PhD with me and with BTS scholarship in Napier. And like backstage, you see the screen. Okay, in the screen, you cannot see so much, but this is the digital twin as a service platform that we have. Actually, it is working. We started as a proof of concept, but now it's improved. I mean, in any use case that we can have, we keep adding a tab and to make the digital twin of it. What we do predictive analysis, recommendations, what-if analysis, what-if scenarios, real-time monitoring. Right now, the already existing tabs for us, already existing use cases are the aeronautical networks. You see the plane. This is one of the use cases. Wind turbine, try to estimate future wind farms, as well as the efficiency of the energy production of wind farms if we can get the data. You can get some free data, so we are using them for now, but we have some nice collaboration for the Scottish government shortly is going to happen. Anyway, smart buildings, we have like an amphitheater in Merkiston, so we are collecting the CO2 levels from the CO2 sensors, the CO2 levels and all this temperature, and then try to recommend in the next 3 hours what can happen. You will see the one action shortly. This is the system architecture. I'm not going to go into detail how we do it, but I will be more than happy to discuss online later on or sometimes later. We have 3 layers: data layer, virtual layer, and service layer. All these 3 layers, of course, are related to lots of research going on, with some patents going on, and then several other projects. We have like a data streaming and distributed processing. We have automation using knowledge graph, one thing that we are really proud of. And the service layer, we do whatever it is asked according to the use case. Data streaming and distributed processing in real time. So we are trying to say that how the data is processed. Since the data comes from different formats, you have to use a particular data set or data structure. Some comes with the JPEG, some comes with the CSV. So we use graph database to capture the relationship among them, not the data itself, but the relationship. It saves some time for us, so we try to use as much as possible the graph databases. This is the one that I was just talking about as a continuation of the previous slide. So how the system is automated, we try to automate all this data gathering and try to embed the information into knowledge graph. So before finishing, so these are the different types of screenshot that I did. They did for me, to tell the truth, my students back in Edinburgh. So we are trying to monitor here, for example. Can I move it? I think I can, yes. Here, what you see is that at time 8:04, the upper screen on the rightmost side upper, this is the reality in this room, for example. But 3 hours later on, according to the LLM that we are using, what may happen in the system, what may happen in that room. So do something. we have some alerts saying that in 3 hours from now, the room will be that part of the room will be quite red. So you may open the door, so you may open the window, or please be careful, don't get more admission to the room, or any other kind of recommendations. Or as we do, we convert the sensors into actuators and make them happen by themselves. So in 3 hours, the door is opening automatically, or this kind of like smart automation that we all know actually. We are not doing something new in that sense, but this commands that is going back and forth on some kind of new. I already showed this. So this is the digital twin enabled aeronautical core network selection. Near real-time air traffic monitoring. So, I mean, I want to say real-time, but I am an academic. I know that in real-time is a dangerous word. So I say near real-time just to be in the safe side. So, I mean, at least keeping the jitter zero, but the delay can be okay. I mean, the delay can be constant, but we try to not to be spiky with the time. This is the whole idea. This is the wind turbine example. These data are quite old. We just used some Kaggle data at the beginning, but now we are improving it with the real-time data. So we try to come up with a new methodology to show the reality and the future. The future of what? The future of energy production and the future of the new wind farm locations. Again, we have here and this is the last, I think the last one. So digital twin enabled green traffic management for transportation network. So what we are trying to do, we try to forecast the emission. On the lower part of the screen, you see like the future. According to your forecasting, you are informing the reality to do something else in order to have less congestion in a road. For example, you try to like grab data in advance or generate data in advance. In this case, we don't grab the data. We don't have sensors there. We have a project going on. Probably we are going to have the chance to collect data in real time. But for now, we are generating the data from Sumo, one of the most famous vehicular network simulator, and using those data as accurate as possible. We are estimating that in that line or in that road, something can happen in the next 10 minutes. So we are informing the algorithm, this embedded system of the traffic lights to adjust themselves accordingly, to be more green or to be more red accordingly. So this is the highlights that we have. Lots of things are going on. We have a book, it's already just published. As I said, we had the best paper going on, another one. And in the IEEE ComSoc, we have this lead editor for this digital twin and the metaverse. So I think it's another milestone for the digital twin in communication society and, of course, in the 6G society. And several invited talks, including this one, saying that I think I'm okay. Yeah, thank you very much for listening.
Should I do it in English? Oh. Dear Professor, I mean, I would like to ask also about the automotive side of digital twin, because you said in your report that the automotive and transport will be the leading in the 5-10 years, will be the leading portion of the digital twin. What do you think about automotive side? Because Turkey is a country that produces its own automobile now, and it's connected and autonomous is the next aims. It will get more complicated, and it needs a lot of testing. So what do you recommend?
Yes, very nice question. Thank you very much. This is one of the industry that we have to focus on. One of the leading industry that we have to focus on, since the data that we are gathering there is quite high quality as much as we can, obviously, but you know, some kind of estimation that you can do in the automation sector can stay there. So you can keep the data and you can still do the digital twin there. I mean, so this is one of the first industry that I am thinking, I mean, honestly, that we'll use, and they're actually using, they are not going to use, they'll start using the digital twin sector, because they have lots of IoT devices already existing in their factories, and transforming those IoT devices into data layer of the digital twin is not an issue as long as you know what you do. So I think this is one of the sector that we will focus on in the near future.
Hello again, thanks for the nice presentation. To get a really good digital twin, you have to collect infinite many data. But we know this is not feasible. So you just try to connect as much as possible in order to imitate reality in real time.
Yes.
And based on that, predict the future. So how do you choose what's the amount of information which is enough to be able to predict correctly the future?
That's a fantastic question, just to make you smile. I don't know. So this is the real question. I mean, the thing that the amount of data that you need depends on the use case, depends on the algorithm, depends on this communication type that you have. So all matters. So just to give an example, in this aeronautical showcase that we have, we try to just collect the locations, like the GPS coordinates and the altitude of the plane, but not all the altitude. We try to run, we say that if this plane is in the 36K feet, since the other plane, according to his GPS, is nearby, it shouldn't be in that level, it should be lower, so we collect this. If it's in the same level, so we don't have to collect. So we are running according to the use case, which is not something that we like. We love it, because the whole idea as a digital twin, like academic people, we try to have like the holistic approach, not changing according to the use case. So right now, the data that we are collecting, obviously it changes according to the use cases, but the whole idea, when we can implement maybe quantum in the near future, or a better graph or knowledge graph methodologies, we can grab everything, but just keeping the relationships live, we can just build up this near real-time digital twin. But it's quite a nice research question to ask.
Well, very much thankful for the nice presentation. Similar to that question, as a follow-up, well, how can we make the machine learning system or artificial systems to learn a little bit faster, so that we don't have to wait that much long to get the actual estimations in a proper way?
Very nice one as well. It depends on if you are talking about the data, you know, you have several V's. So it depends on the volume, it depends on the velocity, it depends on maybe the distance that you are with the data. For example, we can get faster if you collect it and then run it, like what we call edge. Or if you don't collect everything, like the volume, I'm hitting the V, of volume of V. So if you don't collect everything, but you collect in an intelligent manner, you can be quick. Or if you decrease the line of codes that you have, like as a complexity, you can get speedy. But these are all related with the approach that you have according to, again, use case. But we can get really faster while collecting in an intelligent manner, or collect and execute in the fly where that you collect data, or after doing the execution, not publishing everything, but just select the thing that you want in order to have a faster recommendation. It all depends on the data. It all depends on the use case that you have. Thank you.
Sayın Profesör Doktor Berk Canberk Beyefendi'ye yaptığı konuşmasından dolayı teşekkür ederiz. Şimdi hediyelerini takdim etmek üzere Profesör Doktor Lütfiye Durak Atay'ı sahneye davet ediyoruz. Değerli katılımcılarımız, programımıza kısa bir süre ara veriyoruz. Kahve molasından sonra saat 4.45'te ikinci panelimizle devam edeceğiz. Sabrınız ve iştihadından dolayı teşekkür ederiz.